Hey students, and welcome back. In this video I'm going to teach you how to do electron dot notation. This is kind of an outdated method, but what its purpose serves is to give you a way to visually represent the valence electrons that an element has. So the components of an electron dot notation are the element symbol and then dots that represent the valence electrons. Hit pause in your video for a moment and read the directions on the tutorial, and when you're ready to go, hit play. Okay, so now that you've read the directions, you can kind of see what we're going to do here. The first step we need to do is count the valence electrons for an element. I'll talk about how you can do that as we work through our first example. And then we're going to write the element symbol down, and then we'll start at the top. So at the 12 o'clock position on the old analog clocks, and we're going to go in a clockwise direction, adding one dot for every electron, but we only add one dot at a time. So we'll go 12, 3, 6, 9 o'clock, back to 12 o'clock before we start doubling up. Let's work through the first example, and that is bromine. So finding valence electrons obviously is the most important part of this. There's a couple of ways that we've taught you how to do this so far. Notice on the screen that I've given you the electron configuration for bromine. When you look at an electron configuration, what we're doing for valence electrons, those are the outermost electrons. That means you're looking for the highest principal quantum number. If you look at bromine's electron configuration, the highest principal quantum number is 4. It's actually in two different places. And once you pick that out, you simply add the exponents if it's an electron configuration. So I have 2 electrons in the 4s, and then I have 5 electrons in the 4p, so that equals 7 valence. There's another way to do it as well. If you have the periodic table, you can find the element, and here's bromine here, I'll circle it. Here I'm circling it with my pointer. Bromine is in the halogen group, which is column 7A or column 17. Now remember, we just learned we have the main group elements, which consist of groups 1A, 2A, 3A through 8A. So for these main group elements, the valence electrons will always be equal to the column number. So if bromine here, again I'm circling bromine, Br, if it's in column 7A, that means it has 7 valence electrons. So that's another way you can come up with valence electrons. In the example we have, now that we know we need to put 7 dots in, we begin by putting the Br symbol. And then this is representing that 12 o'clock position that I told you about. That's our first valence electron. And then the second dot goes in the 3 o'clock position. And then the 6 o'clock position. And then we get back to the 9, and then finally to the 12 o'clock position again, where we finally start doubling it up. And we just keep going in the same circle. So back now 3 o'clock position, and then the 7th and final dot goes in the 6 o'clock position. So we've got now 1, 2, 3, 4, 5, 6, and 7 dots. 1 dot for every valence electron in bromine. Some of you may be wondering now, where do they come up with this? Why do we put dots in these 4 positions, and what do these 4 positions represent? Well, really, the original intent was to have spots around the element symbol that represented the s orbital, and then for the main group elements, that would be the 3 different p orbitals. The main group elements all have, they obey the octet rule, so you have between 1 and 8 valence electrons. So those 4 positions with their 2 dots each would give you the 8 valence electrons. The d orbitals aren't important for the main group elements. So this electron dot notation really is only good for columns 1A through 8A. So it's kind of pointless in a way, but what we're teaching you here is how to count valence electrons for the main group, and that's first year chemistry stuff. I bring that up because in the second example for calcium, we pick out its valence electrons, we see that there are 2. And so as you see in the answer here, the symbol Ca, I have 2 dots. And according to the rules you start at 12 and go to 3. And that's following the rules that have been set for us. Well, somewhere along the way, the rules got adjusted or simplified because that doesn't really accurately explain what the electrons are doing in the electron cloud. It would be really better to write that as 2 dots in this north position, 12 o'clock position, because those dots would be in the s orbital together. And I believe, and I don't have any proof of this, but I believe what happened was as the years progressed, teachers tried to simplify this for students, and so it was just easier to teach students to go around in a circle twice instead of having to think about S, PX, PY, PZ. But the bottom line is we're not going to do it the right way. We're going to do it the way that convention has evolved. So go around in a circle twice. So this is the answer I want you to go with. All right, I want you to do some examples now. We're going to work through a couple of these together. The first one is phosphorus. So take a moment and figure out how many valence electrons phosphorus has. And you will get 5. Okay, so we're going to draw that dot notation. We're going to put 5 dots starting at the top. 1, 2, 3, 4, and now the 5th one goes back up top where I can double it up. All right, let's do krypton. How many valence do you see for krypton? If it's noble gas, the answer is not 0, it's actually 8. Now as you draw krypton, we've got Kr. 8's an easy number. We know we're going to fill everything up, so I'm going to go around in my circle 2 times. So there is krypton. All right, I want you to kind of hit pause here and work the rest of these 4, and then I'll give you the answers to check at the end of this. Okay, let's see how you did. We have sodium, Na, with 1 valence, so we'll put a dot on top. Oxygen has 6. 1, 2, 3, 4, 5, and 6. Chlorine has 7. 1, 2, 3, 4, 5, 6, and 7. And aluminum has 3. 1, 2, 3. And that's all there is to it. If you have any questions, come by and ask Miss Sloan. She's always willing to help better than me.